temperature gauge here, just doing some temperature tests. So, what do we got here? So the wall is 20.2 degrees, and my cell is 18.4 degrees. So it's about 2 degrees cooler than the regular room temperature. These have been running for quite some time now. Just doing some ambient temperature testing. So 20, and then my cell is 18.5. So the cells are cooler than the ambient temperature of the room. Give me a thumbs up if you like the video. So I'm just testing away. I got my cells hooked up to a scale to see if I'm losing any mass. So they're kind of inconclusive. I had some anomalies, but I can't really specify if it actually was a true anomaly or not. Some tests I did under a load, it decreased a bit of mass, but it's inconclusive, so I can't really, you know what I mean, like actually state that that's what it was happening. So it's kind of inconclusive because the numbers are so tiny to actually prove that under a load these batteries are actually losing mass. I can't really specify if that's true or not because the numbers are so minute. Now if I did cool it off and then I took it off, alright, reset it to 0, as it was warming up, it seemed to gain weight. So, still, I can't really conclude that there's an anomaly there. It could be a number of factors. It could be the water that's trapped in the cells are evaporating, therefore it's making it lighter, or if I put the damp cloth on it, it's gaining weight. So it's kind of really inconclusive, so I can't really say it's losing weight under a load. So yeah, I'm just toying around with it, thinking of different configurations. So yeah, I'm just kind of messing around with it. Still charging supercaps pretty good. Yeah, it seems to be at least 2.5, almost 3 degrees cooler than the ambient air around me. Like if I point it at the wall, I'm getting 19 or 20 degrees Celsius. So I can't really, it does appear that it is cooler. The batteries run cool, so when you put the damp towel on it and energize it with the water, even though that I take it off for quite some time, it still stays a lower temperature than the ambient around in the room. So whatever reaction that the cells are making between the water and the magnesium, there is some kind of cooling effect going on there. Now it's not like it gets warmer over time. Even when the cells dry right out and they're not producing a lot of power, they're still cooler. And I think that's kind of an interesting thing. So for some reason the water and the magnesium have some kind of an effect on temperature. Now I did put these in the freezer for about 30 minutes, the cells in the freezer, and I super cooled them down. and it seemed to lose the power, but the second I put the towel back on it, it came alive again. So I don't know what that means. I truly feel right at this point it's a reaction between the water and magnesium. There's some reaction happening there. So um, obviously it's a cooling effect, not a heating effect. So it's not generating heat, but it's making temperature go lower, but it's creating power. Now, if I just cool it right off and everything freezes, if there's no active water there that's at, plus 0 degrees, I lose the electricity in it. There's no power flowing. But the second I put the wet towel on it, the cell comes alive and stays cool. It doesn't warm up. So, yeah, as far as condition of the cells, it's been, going on 2 days now. They're still pretty healthy looking. One cell here looks like a little bit of corrosion's happening. That's probably just because of the water being exposed to it, or it could actually just be dirty. Seeing if I could actually scrape some of it off. Yeah, I think it's just dirty. Yeah, the cells are holding up. Now, if you use a salt water, these are going to deteriorate within 5 days. They'll literally just start crumbling. So you don't want to use salt water. I've been using my structured water from my water machine, and it seems to have really good conductivity. The paper towel that's in between the graphite and the magnesium, it absorbs that water, that moisture, and that's what maintains power. So, like these ones here, the connection's almost lighter. Can we get that? Like it could be my wires too. So I do got power. So yeah, I'm just kind of messing around on the computer, doing some experiments. So it's my birthday today, so happy birthday to me. And yeah, wife's at work, daughter's at work, or school. And yeah, so I am 49 years old today. Yeah, so just kind of doing some research on the computer here while. Oh, one thing I wanted to show. This is the new dielectric I'm going to start using. To make my new cells. In Canada, we have in Canadian Tire in Canada, they make these paper towels. You could probably get them in the U.S. too. They're like blue. In the package here. They're made by Scott. They're called shop rags. They're a polyvalent. They're made in the U.S. So there you go. It's got the American flag on it. So they're made in the U.S. And I'm going to use this because, number one, they don't deteriorate like a regular paper towel does. These ones are actually quite a bit more durable. They're stronger. It's almost like I don't know if you can see that, but these are really durable. They don't break down. So and they're little tiny, they're about, I would say, the same thickness as a regular paper towel. So they come in strips like this. And that's what I'm going to use as a dielectric when I redo some cells. I'm probably going to build more of these. And it takes quite a bit to actually rip these. they're pretty durable. Like paper towels rip up a lot easier. So, yeah. Just let me check something here. People sending me happy birthday messages. Yeah, it's Mikey's birthday today. So, yeah, so this towel I'm definitely going to use to make the cells. I think and the absorptions, I think it's going to be a lot better. It's going to hold a lot more moisture in it. So, yeah, I'll be using these. What else? Yeah, I can still charge up super caps, and it doesn't take very long. A couple minutes, and this thing's charged up, and it'll run for several hours. So, actually, almost a full day. So, yeah, I'm just toying around with ideas, construction, trying to figure out what's going on, if it's losing mass when it gets cold, or what's happening with it. So, the mass thing, I'll just have to say no at this point because the meter readings that I'm getting are kind of inconclusive. Because there's other factors, like is it absorbing water? Well, if it absorbs water, then it gains mass naturally, right? And also too, as it's drying out, it's going to lose mass. So it's going to be hard to really detect an anomaly. But I'm not really too concerned about the mass and the weight and all that kind of stuff. But it's the amount of power that I'm getting out of this. Like what I did notice when I did super cool it, I put it in the freezer for about 30 minutes. Then I put the water on it. It actually increased the voltage now. It was hitting about 8 volts. Under regular conditions, it was about 7.2. And then when I put a load on it, it would go down to 6.2. So I lose a volt. And then when I super cooled it, put the wet rag on it to charge it up, my voltage went up to 8 volts. So, yeah, I think there is a correlation with the power output versus temperature. So if you can keep it wet, keep it cold, you get more power. So that's kind of good to know. So the colder you keep this and wet, you get the best performance out of it. So a cool, wet area. So that would probably make things work a lot better. Maybe that's why putting it in the ground, like Nathan Stubblefield did, he would shove these earth batteries in the ground to keep them moist and also cool. So that's probably how his coils were working. I think these work on a similar type of science that he was doing, but I don't believe he was using magnesium. He was using iron core, using iron, dielectric, and a lot of coil, copper coil around it, and he was getting power out of it. So, and he would stick it in the ground. He would dig a hole and put the cells in the ground with the wire coming out. Put it 2 good grounds, and then his receiver antenna would be 2 iron rods, 2 iron rods. He would go several, meters away, stick them in the ground, and then he would receive the power from the transmitter. So Nathan Stubblefield is what you want to look into. I've been studying him for a while. He was a farmer, and he came up with basically an earth battery. And at one point, Tesla actually, and a bunch of engineers actually went to visit him. And Tesla later down the road came up with radiant energy and was able to get power out of the ground. So it makes you think where he got the idea from. He probably got it from Stubblefield. So Stubblefield was doing this pre-Tesla. So these have been running for quite a while. I'm going to do a dead short test on this. I just want to see how many milliamps this thing's pulling. Do a dead short on it. Let's see what the meter tells me. Yeah, so this one's been running for quite some time, and these cells are really dry. So it's pulling about almost 30 milliamps, dead short, which isn't very much. So I probably have to soak these cells down quite a bit to get the power back. Light back on. Yeah, so what I'm going to do is I'm going to wet this rag and then I'm going to soak them. And I should be able to notice quite a difference. So I'm soaking this down. Just leave that on for about a minute or so. They seem to be gaining strength. Let's turn the light off here. Yeah, they're actually getting stronger now. You can see the light. See from off and back on. So they're putting out quite a bit of power. They are getting brighter, I can tell here. It's kind of hard to tell on the camera. So I just let these soak for about a minute, and then I take it off, and this thing will run for several hours. My one test I did, the cells were putting out power for 8 hours, actually almost 9 hours continuous. And it's a steady drop. It's not like a sudden drop in power. It's a very steady decline in power, which is a good thing. So, actually, I'll hook it up to this one LED bulb. This one's pretty bright, so you can kind of get an idea how strong it is. I'll point it right at the phone. You can see it. It is putting out a lot of power. This only takes 2.5 volts at 20 milliamps, so it doesn't take much power. So, yeah, you can see how. Kill it. It's very bright. So yeah, puts out quite a bit of power. But I hook it up to these ones because these only draw about 20 milliamps, these LED lights here. But I'm putting in a good 7 volts of power, so these things are actually quite bright. Just the connections are kind of faulty. Connections on these lights aren't the best. Yeah, so that's about enough for the cells. I don't really have to put any more water on it, and these things will run for quite a while. Or you could just leave the rag on it. You can do that too, but I think you'll contribute more to the deterioration of the magnesium. So I could always just leave it on. Actually, at one point I was leaving the rag on all the time. Yeah, zinc, silver. Yeah. Let's see here. Zinc, silver, copper, and bismuth. What else? Any tips on what inverter? Uh, you can buy these little inverters from Amazon. They're like this big, and they're like $15. Look on Amazon. It takes a 12-volt battery source, and you can get 40 watts. There's some real small ones. Or you can take that DC voltage, all right, put it into a PWM with a spark gap, like a auto relay switch in a coil, and you can actually modulate your own AC power and power, a 120 volt AC light bulb. You can check some of my videos on my YouTube channel, um, how I do the pulse motor, and it runs on DC power, but I'm lighting up 120 volt AC lights with it, LED lights. So yeah, in that way, it's actually like an inverter. So it's like a mechanical inverter using a spark gap switch, a auto relay switch. That's why I'm able to get those high voltage spikes enough to actually sustain a light bulb. So yeah, that's about all I'm doing right now. I guess yeah, I'm gonna go out for a smoke here and see. Yeah, no problem. Yeah, just look at all my videos on my YouTube channel, Faraday Research RND. Yeah, just check those out, and you'll see what I'm doing. I actually implemented piezo transducers into the pulse motor, and that gets the voltage even higher. So you can try that out. Anyways, I think I'm gonna call it quits here. Yeah, it's my birthday today. I might show up tonight on Crypto Alchemist live stream, so you can tune into that. We were supposed to do one last night. I don't know what happened. I guess Bernie had something come up. So, yeah, yeah, we'll see everybody soon.